Good morning, everybody. It looks like we're going to have quite a storm on Sunday into Monday. Well, Sunday's going to be the big storm. Well, Monday's going to be extremely windy, especially in the morning. Gusts to 60 miles an hour likely. Look at these winds here. 60 knot winds at just 925 millibars. So winds at 2,000 feet will be up to 60, 70 miles per hour. 60 knot winds. That's about 65. That's about 70 mile an hour winds. And winds close to 70 miles an hour, just around 2,000 feet. So that'll be about gusts of 50, 60 miles an hour ground level. So high wind warnings are definitely going to be issued for this. Let's look at the NAM right now. So looking at the NAM right now, showing, whoa, look at these winds. I mean, of course, that's going to be off the coast. The GFS is not really showing that, but look at these winds here. Monday afternoon, winds gusts about 50 knots. Temperatures are going to be falling throughout the day. So let's look at the temperatures for Monday. It looks like temperature high of 52 degrees, upper 50s. Looks like it's going to be pretty cold Monday. Look at that. Just cold air just splashing right in. I wouldn't be surprised if there's going to be some cold air aloft showers. Because, the sun is a little higher in the air now, so just very windy day. It's going to be very windy. There's going to be wind damage definitely possible. So let's look at the the NAM through KM. The high resolution NAM is showing freezing rain entering Pennsylvania, so it looks like some freezing rain is possible. So this is when it's going to be really windy. So this is when you get a wind gust of 50 to 60 miles per hour, potentially. I'll say gusts of 40 miles an hour is definitely possible. Look at this, surface temperatures in the upper 30s. But here, there's even some temperature of 32 degrees. So the water temperature is very cold. It looks like some of the strongest winds, I think, will be behind the system. So let's check again, looking at the the NAM through KM. Yeah. Sorry, I get confused with these models. Look at this. Wow, look at these winds. Gusts up to 50 mile an hour winds here. I mean, look at this right here. This is a low level jet. This is what I call a low level jet right here. See, the winds in New York are still out of the south, but here you have southwest winds. So this is where you get winds of 60 miles, 50, 60 miles an hour screaming in. So see, you have a bit of a low level jet right here. See how it has warmer temperatures? So you see, there's definitely potential of a bit of a low level jet coming in with this. Now let's look at simulated reflectivity. There's definitely convective action. Look at this here. Right here. Those are wraparound showers behind the front. This is Windstorm Quiana coming in. So it looks like the storm could definitely have some very strong winds with it. Potential for strong and damaging winds definitely exists. So I believe a wind advisory or high wind watch or even a warning will be issued in the next 24 to 36 hours. So now let's look at the European. European doesn't show any. Oh, look at that. Okay, potential for a snowstorm here. Okay, let's go to regions. We're going to go to the North Atlantic. So you see there's a system right here. You have a low here, you have a low here, you have a high here. Normally this would dictate the storm that it's going to go northwest, or I mean northeast. So look at this. So you have a storm here. So by the looks of this, I don't think this is going to bring any snow. I mean, thermodynamics. Okay, I'm gonna. So let's go back to the United States now, because I can't get thermodynamics. So, but I don't think this system is going to bring any snow, because it's going to be too far off the coast. We might get a little bit on the edge. Plus, there's a fair amount of warm air, so I think this is going to be primarily a rain event. And this system looks like it's going to go out to sea. Let me check upper dynamics, 500 height anomaly. It will dictate which way the flow is going to be. Looks like the storm's going to sliding east northeast. Looks like this storm is going to slide from the west southwest to the east northeast, basically. So there is going to be, the storm is going to try to come up the coast potentially, but I don't know. Lower dynamics. Let's look at the anomaly, mean surface level pressure anomaly. So it looks like some snow is possible from this system. I mean, this is all going to be on March 4th. This is very far out. So this is the wind event that's coming in. This is Windstorm Quiana. Very strong winds expected. Damaging winds, gusts 60, 70 miles an hour, definitely possible. I mean, look at these winds here in the Great Lakes regions. I mean, just check this out. I'm going to show you the Great Lakes regions. I mean, just check these winds out. These are going to be ferocious winds. Just ferocious. Look at these winds. This storm is going to have wind gusts of 50, 60 miles an hour easily. I mean, especially Sunday, I believe. Okay. Just check out these gusts for the Great Lakes. Let's look at Sunday afternoon. I mean, not Sunday, Saturday afternoon. Check out these gusts right here. This little, that is 60 knot winds. That's severe criteria. That could actually be a thunderstorm coming in, or it could just be winds. Because at that time, it shows, yep, thunderstorms. And it looks like Wisconsin's going to get a big thumping of snow from this. I would say at least 4 to 8 inches, at least, maybe even a foot. Definitely a significant amount of snow for Wisconsin from this. I would say at least a foot of snow for this region here. Yep. This is where the core of the snow is going to be, right around this area. At least 1 to 2. Yep. Let's look at Cohera. This is the, yep. So I wouldn't say that much snow, but definitely snow. It's going to be a heavy dose of snow and freezing rain, I believe. It's also going to be definitely freezing rain with this. Oh my goodness, a heavy freezing rain event. Yep, freezing rain, definitely. Here's when the freezing rain is going to start in. It's going to start around Saturday. So Saturday is going to have some pretty heavy freezing rain. Why is it going to have so much freezing rain? Because check this out. Temperatures are going to be in the 20s. You're going to stay in the 30s. Let's go to precipitation type. Okay. So now you're on the backside, you're going to get snow. So sometimes, like here in the East Coast, when we get freezing rain, it's usually snow, then sleet, then freezing rain, then it goes to rain. Or it ends at freezing rain and then it all melts because it gets warmer. Here it's the other way around. You're going to have freezing rain and it's going to change over to snow on the backside. So this is going to be a very heavy freezing rain event for Wisconsin. And looking at the NAM right now, this is the NAM itself. It's also showing a pretty healthy dose of freezing rain. It's showing freezing rain, then a change over to snow on the backside. So this is pretty impressive if you ask me. So this is looking, again, precipitation. So here the GFS actually has all rain and heavy, very heavy snow. I mean, look at this. This is extremely heavy snow here. 1.75 inch snowfall rates. That's like this color. That's extremely heavy snow. It's actually very, very unusual. Yeah, so this is going to be very heavy snowfall rates here. Yep. And I'm going to check the Kohara method. This is when the heaviest snow is going to come down. Right around this time, and very cold temperatures aloft. Yep. And if I'm going to be correct, if I'm going to boom, right around this time. Okay, so let's check. Right around this area, I would say about, let's say about close to 20 inches of snow, I would say. Actually, wow, okay, maybe not that much. But blizzard warnings will definitely be issued for the storm. Okay, let's check. I mean, this is what the GFS is saying. The NAM is saying something else. This is looking at the Midwest area. NAM is showing, so this is the storm right here. So you're going to have about, so central Kansas here is going to have, I would say, say a 12-hour storm here. From here, from right about here, so that's 39, hour 39 right here, to hour 51, it's a 12-hour storm. Oh. It's only going to be an 8-hour storm, much less for 12 hours. I mean, this is going to be a very quick hitting storm. In and out just like that, boom. It starts at hour 37, not even 10 hours. This is going to be, I would say, for the snow, 10 hours maybe, that's it. Very quick hitting. Using the Kohara method because it's more accurate. So about just 7 or 8 hours. There's going to be accumulation of swath of about 6 to 10 inches of snow. Yep, about 6 to 10 inches just in a few hours. Definitely warrants winter storm warnings. So you're going to have snow here. This is with the core itself. This is Winter Storm Koyana. I mean, this is not going to be like a historic blizzard. It's going to produce quite a bit of snow, but it won't be historic by any stretch of the imagination, but it's going to produce quite a bit of snow. Now I want to change my gears to volcanoes. So I'm going to go to volcanoes right now. We're going to look at seismograms right now. Some volcanic tectonic earthquakes. You see this triple swarm right here did not appear in Batur. Did not. However, the reason for this is because these are volcanic quakes that originated from Agung. These are tectonic quakes. These quakes here, these 3 quakes here, quakes you see here are related to Agung, because look, Ranjani, I think that actually might be related. No, because usually most of the quakes that you see on Agung are related to the, like sometimes if you see a quake here, and usually when we had that big earthquake, it showed on every seisma. I first noticed it here, and I could not pinpoint the exact location until I went to USGS and found out the origin was from here. Actually, it was after that crazy earthquake storm that Ranjani had, that Lombok had, that they put this here. And it looks like, look what's happening. Look what's going on in Ranjani right now. There's a bit of a swarm going on. I mean, this is a super volcano, by the way. It had a VI7 eruption, and it's actually a Soma-type volcano, a volcano within a caldera. In fact, it's a Soma-type volcano. It means it's a volcano within a volcano. It's basically the same volcano. See? Is a volcanic caldera that's partially filled by a new central cone. The name comes from Mount Soma, a stratovolcano in southern Italy, with the summit caldera in which the upper cone of Vesuvius has grown. Actually, Mount Soma, the one before Vesuvius, actually had I would say, almost a super eruption. This is actually a caldera, and Vesuvius is in the caldera. This is Vesuvius. This is Mount Soma. This is Mount Vesuvius right here. My bad, actually. So Mount Vesuvius is a Soma-type volcano. Well, actually, so is Ranjani. Ranjani is a Soma-type volcano, with Ranjani being the new cone and Samalas being the old one. In fact, Mount Vesuvius, Mount Soma, is that volcano. Its age of rock is 25,000. I mean, it's a pretty new volcano. It's geographically very new. It's 25,000 years old rock. Lava falls of 1944. Mount Soma is a remnant of a large volcano. But here's the thing. Geography. See, it had a caldera. They're not saying how big it was. Actually, yes. Right. This is where you need to go. Before AD 79. So we started erupting in the Koloda. They said, I think it was VI6. Okay, the African and the Eurasian plate, okay. 25,000 years ago. The Kodola. Oh, right here it is. Right. 18,300 years ago. The base of pumice VEI6 eruption. That's like Krakatoa and Mount St. Helens. Not even Mount St. Helens. Krakatoa and Pinatubo type. That's world-altering climate change strength type eruption. The eruption is followed by a period of much less violent lava-producing eruptions, which means it went from more andesite to more basalt, or less explosive lavas. But then guess what happened? 300 years later, the green pumice of VI5 occurred. 11,000 years ago, you had a big eruption. 8,000 years ago, you had another VI6. So this volcano is very active. 100 years ago, you had a VI5. So basically, you had a gap between 3,800 years ago and AD 79, which is about, I would say, a little bit over, not 3,000 years. The volcano was quiet for 295 years, which means, so this volcano has frequent eruptions. So it's not like this was the last eruption. No, in fact, 295 years was the previous eruption. And you had subsequent eruptions after that, so large Vesuvian eruptions, which emit volcanic material, have happened after periods of inactivity of a few thousand years. So that's a good thing. Subsequent eruptions, such as those of 1472 and 1631, have been more frequent, with a few hundred years between them. From the 1631 eruption until 1944, there was a comparatively small eruption every few years, emitting 1,000th to 100th kilometer cube of magma. It seems that for Vesuvius, the amount of magma expelled in an eruption increases very roughly linearly with the interval since the previous one, at a rate of around 0.01,000th cubic kilometers for each year. This gives an approximate figure of 0.06 cubic kilometers after an eruption after roughly 6 years of activity. But here's the thing: guess how much years of inactivity we already had? We already had 65 years of inactivity. So let's get through the math, right? Let's do the calculator now. So 0.01. So 0.001 times 65. So 0.065, which is basically normal. 0.001. So in order to have that amount, you'll probably have to have 1,000 years of inactivity. See? Then you'll get 1. So Vesuvius will probably need another 800 years of quiet. I mean, it's possible that these tiny eruptions are only releasing a small amount of the pressure because the last big eruption. So this is about after 100 years of inactivity. Eruptions in the 20th century. So you had an eruption of 1906. So the eruption of 1906. 57. No, I don't think that was what I was looking for. Okay. 58. Let's see. This is an old article. 1,000 foot column of fire, lava. So it's a lava flow. Okay, so this is more of a lava flow type. There's no. The major stream of lava proceeding from Vesuvius is 200 feet wide, and it's advancing 21 feet a minute. So there's a column of fire. So the glare of light, let's see, okay. Whoa. Okay, so basically, eruption. Let's say from 1930. 1930 to 1944, with lava filling the crater and occasional outflows of small amounts of lava. So this volcano is also capable of effusive eruptions like Hawaii too. Strombolian activity. The eruptive period ended in a major eruption of March 1944, which destroyed a village of San Sebastião Vesuvio, Massa di Soma. Wow. So lava flows appeared within the rim. There were outflows, small explosions occurred, and then there was a major explosion that occurred on March 8th, 1944. The eruption could be seen from Naples. So, Vesuvius, March 8th, 1944. Most recent eruption. Alrighty. So you can see the ash coming out. So let's watch a little video on Mount Vesuvius. This is from Periscope film, This is
Your commentator is Robert Stevenson. Vesuvius explodes. Italy's historic volcano bursts into the most fearsome and devastating eruption in 70 years. Over the fiery crater, a great pall of smoke and lava dust spirals into the sky, a giant specter of endless grief for the Italian people. Suffering under many years of brutal fascism, then German occupation, then Allied bombing, then the devastation of battle, now it is Vesuvius. Suffering under many years of brutal fascism, then German occupation, then Allied bombing, then the devastation of battle, now it is Vesuvius. At least once in every century of the Christian era, it has hurled disaster. The city of Pompeii was buried when the huge mountain first thundered into volcanic life in the year 79 AD. Thousands of Italians perished. Excavations have revealed their tragic story. This was a pleasure resort of wealthy Romans almost 1,900 years ago. Rising 4,000 feet above the fertile plain of Campania, Vesuvius lazily pours forth a harmless curtain of smoke. Naples, 10 miles from the slumbering peak, lies in comparative safety except for the deluge of volcanic ash that will blanket the city. Then, with a few warning rumbles, Vesuvius belches fire, flame, and molten rock in a fearsome spectacle. Tons of ash and cinders are borne skyward, while fiery lava streams down into the doomed valley. The overflowing crater erupts with a mounting temperature of liquid steel close to the summit, which carries its fiery heat long after it loses incandescence.
You see this video right here? You see this, how this lava flows?
Overflowing crater.
Yeah.
Down into the doomed valley.
This is actually from Vesuvius, and you see this looks like the Pahoa lava that you get in Hawaii. Like basalt. This flows like basalt. This is definitely not rhyolite or andesite. But it's not basalt because it's explosive, and it's not rhyolite. So I think there's another term for it. I think it's I'm gonna look it up actually right now. Magma types. Just look up magma types. Okay. this is what I think is better. It's a composite volcano. There we go. I think this is a good website to use. So you have flickering fields, that's Vesuvius, that's Soma. Actually, this is all Vesuvius. Soma and Vesuvius is actually one volcano. At a VI 18,000 years ago. So Vesuvius, that's the flickering fields. That is Isha Island that had a 4.3 volcanic earthquake that killed about 3 people. Aha! A tephrite is basaltic in character. The rocks are called tephrite. Yes, that's the one I was looking for, tephrite. I think there's one other volcano that's tephrite. Tephrite volcano. Well, thank you for watching. Have a great day. Actually, just before I go, just want to visit some Icelandic volcanoes. See, activity seems normal. See if there's any earthquakes around Ladrasea. Looks like there's none. So it looks like there's a Clear Lake. And it looks like there was an earthquake right near Taupo of that. There was a bit of a swarm there. Let's go magnitude 2 plus. Anything near? Looks like there was a magma chamber volcano. That's related to the volcano. If it's less than 10 miles, I would say it's definitely related to the volcano. And probably not subduction. Subduction definitely. Let's check magnitude 2 plus. Let's go for all of January. Show for the whole month. And it looks like anything that's magnitude 2 plus. There's a couple that's related to the volcano. All the shallow quakes, I believe, are definitely related to the volcano. Especially this one probably is not, definitely not. Okay, let's go for all of 2018. Okay, perfect. Alrighty, whoa. There was a swarm right near the earthquake. Looks like, I would say March of 2018. Show. Yep, looks like there was a swarm right over the volcano. Yep, zeroed right over the volcano. So you had a bunch of surface tremors. That's very bad. You had basically a large earthquake swarm right near the volcano. Let's go for all of 2017 and see again. Righty. Oh my god. That's right, in March, April, let's say. March 2017. Yep. 93 plus, 4 plus, and there you go. You had an earthquake right near the caldera. Magnitude 5 plus. Magnitude 2 plus. Right around March 29th. At a magnitude 4.5, and it looks like it occurred 21 kilometers from the volcano at 6.4 kilometers depth. So probably not volcanic related. In fact, let's go to April now. So looking at this, let's see. That's definitely volcanic. But the distance, all of these have pretty big distances here. How about that 6 kilometer one? Nearest volcano Tapo, 6 kilometers. Alrighty, let's go for all of 2016. All of 2016, oh, perfect. Let's see, anything interesting? Okay, that's definitely not volcanic, or could be volcanic related. Looks like November. There's a pretty big swarm there. Let's see, anything near the volcano. Nearest volcano, Tapo. Yep, that's a faultful. Probably strike slip. Or that could be subduction related. Let's go magnitude 4 plus. Okay, let's go for all of 2015. So very seismically active here. But you had a very, okay, looks like December was pretty seismically active here, especially around the 11th, 12th. Nothing too impressive there. Just want to see if there's anything going on. There's earthquakes near Vesuvius. Small swarming. Let's go to all of 2019. Nothing much going on. Some small swarms going on. Let's go for all of 2018. Oh, look at that. And right towards the end of the month, boom. I mean, right towards the end of the year, all of 2018, it just started swarming. Did this happen in 2017? Not really. Actually, it started to get active now. I'm going to check if this happened in the last few years. So, yeah, definitely some active swarms. 2 plus. So Flag Rain Fields, there was a 2.1. Very shallow 2.1 quake. You had a 2.1 in Naples. Let's check info. They give me a latitude, longitude. Not related to any volcano. Wait, or is that Vesuvius? Aha, so that is a Vesuvius related quake. That was the one that said that's Vesuvius. Vesuvius there. Okay, let's go to all of 2015. Some pretty good swarms here. Let's go magnitude 2 plus. Vesuvius area, 1 kilometer deep. So Vesuvius is definitely having some pretty active eruptions. I mean, earthquakes. Alrighty, let's go for all of 2014. Not really. All of 2018. Let's go. And there we go. So December 2018 had some swarms. So it was November, end of November, beginning of December. They had some pretty good swarms. 2.3. Shallow one too. That's not good. But on average, Vesuvius, ooh, that's some pretty good swarms. Look at that. Magnitude 3 plus. Let's go magnitude 2. Vesuvius area, 2.1. Southern Italy. Nothing near Vesuvius. It's just a 1 quake. Let's go to December of 2018. 2 plus. So Vesuvius. Oh, look at that. That's some pretty good quakes going on around Vesuvius. So the fact that there was a pretty big quake recently, but it looks like Vesuvius is calming back down. And that one, yep, looks like all that activity around Vesuvius is calming down. But that's definitely a sign that magma's rising. Thank you for watching. Bye.